Okay, we're ready to start section 2.3, which has some more derivative rules that we need to learn. As I've said before, the proofs of these are in your text, but when I ask you to read the text, don't get bogged down in trying to read those proofs because some of them are really hard to follow. And at this point, it's not that critical that you completely, totally understand the entire proof. It's really more important that you can apply the theorems at this point. So, glance through the proof, but don't let it bother you if you can't follow it completely. The main thing is to go through the examples and make sure that you can do those. Okay, here's the two new rules we need to learn. If you think back to the notes that you had in section 2.2, you learned some derivative rules. The only one that involved any kind of multiplication was the constant multiple rule. I'm going to write this up at the top. It was that if you had the derivative of a constant times a function, the constant stayed there, and then you took the derivative of the function. But we didn't have any rule that said what to do if you were multiplying two functions or dividing two functions. Yeah, we have one for adding and subtracting, but not multiplying and dividing. Turns out if you're multiplying or dividing two functions, you need to apply some special rules called the product rule or the quotient rule. Here's the product rule. If you want the derivative of the product of two functions, f of x times g of x, then this is the rule. You start by holding the first function the same, so f of x, and times it by the derivative of the second function, g prime of x, plus, then you hold the second function the same, g of x, and multiply by the derivative of the first, f prime of x. So you can see it's a little bit more complicated than just taking the derivative of each one separately. Okay, because all those f of x and g of x's are kind of long and hard to say, sometimes we write it in a shorthand like this, the derivative of u times v, where u is the first function and v is the second. And then we can just write that it's u dv, that means the derivative of v, plus v, and then du, the derivative of u. And that's the way you're going to hear me refer to it most of the time. Okay, the quotient rule looks even worse, but really isn't that bad. So if I want the derivative of a quotient, f of x over g of x, then this is what I do. I start with the bottom function, g of x, and multiply by the derivative of the top, minus the top function, f of x, times the derivative of the bottom. It's all over the bottom function squared. Remember, you can pause this video at any time and take your time and write that down and say it to yourself 2 or 3 times. Okay, again, it's kind of long to say with the f's and the g's, so we often say it instead with u's and v's, where u is the top and v is the bottom. It goes something like this: v du minus u dv over v squared. You need to memorize these, so I would suggest you kind of pause it and say them to yourself 2 or 3 or 4 times. Now, one important thing to note. On the product rule, the order actually does not matter because addition is commutative. It doesn't matter what order you add things in. But on the quotient rule, because it has subtraction, that order matters. You have to get the order straight. So say it to yourself 5 times so that you get that order straight, because otherwise you'll get a negative answer instead of positive, or positive instead of negative. Okay, let's try applying these. Okay, so the first one, I want to take the derivative of 3x squared minus 5 times 2x plus 7. Now I could go ahead and FOIL that all out, and then I would just have a polynomial and I could take the derivative like I did in 2.2. But I'm going to try using the product rule. So I'm going to call this first part u and this second part v, and then I'm going to be applying this product rule up here. And again, I like to do it with the u's and the v's. So here we go. Y prime equals. Okay, according to the rule, I write my u, so 3x squared minus 5, times the derivative of v. Well, v is 2x plus 7, so the derivative is 2. Plus the v, 2x plus 7, times the derivative of u. The derivative of 3x squared would be 6x. All right, that's fine. That's it. I've done the derivative. But I could go ahead and multiply it out and clean it up. So if I distribute, I'll get 6x squared minus 10. If I distribute this, I'll get 12x squared plus 42x. And if I simplify then, it looks like I get 18x squared plus 42x minus 10. Okay, you may want to pause and just read through that again and make sure you've got it. If you think you do understand the product rule, try number 2. Pause the video, try it on your own, then start the video back up and see how you did. All right? Okay. Here's the solution. F prime of t equals, okay, think of the t squared as your u and the sine t as your v. So using the formula, it's going to be my u, t squared, times the derivative of my v, and the derivative of sine t is cosine t, plus my v, sine t, times the derivative of my u, and the derivative of t squared is 2t. All right, that's it. That's the answer. To clean it up, I just put it in a little bit better order. So t squared cosine t plus, now usually when you have something multiplying a trig function, you put that something in front. So I'm going to write 2t sine t. That's a very good answer. The only thing is sometimes you will see it in factored form. The greatest common factor is a t, which leaves me with t cosine t plus 2 sine t. But you don't have to do that. All right, let's try a couple of quotient rule problems. Okay, so in the quotient rule, the numerator I'm going to call u, and the denominator I'm going to call v. So you have your quotient rule in front of you. If you want to give this a try on your own, just following the quotient rule, then pause the video and try it on your own. And then you can check with my solution. So here's the solution. Y prime equals the denominator 3x minus 4 times the derivative of the numerator. Derivative of 5x plus 7 is 5. Minus the numerator, 5x plus 7, times the derivative of the denominator, 3. It's all over the denominator squared, 3x minus 4 squared. Now let me give you a hint. You don't need to FOIL this out. It's just fine the way it is. Okay, now the biggest mistake people have on this is simplifying the top. Be sure you keep track of that negative because that's going to cause you some trouble if you're not careful. Okay, if I distribute, I get 15x minus 20. Now careful, like I said, if I distribute this, I get negative 15x and I get negative 21. Okay, all over 3x minus 4 quantity squared. Looks like if I simplify that, I get negative 41 over the quantity 3x minus 4 squared, and that's my answer. Perfectly good. All right, if you think you've got it, try number 4 on your own. Pause it, and then wait to see my solution. If not, you can watch me do the solution. Here we go. I'm going to call the top my u and the bottom my v, and I'm going to apply the quotient rule. So g prime of x equals the denominator x times the derivative of the numerator, which would be cosine x, minus the numerator, sine x, times the derivative of the denominator, which would be 1, over the denominator squared. So it looks like I get x cosine x minus sine x over x squared. And that's it. I can't reduce it because there's no common factor amongst the top. All right, if you think you've pretty much got that, then I want you to read the text, pages 119 to 122. Remember, don't get bogged down in reading the proofs of these rules. Instead, focus on looking at the examples they give and making sure that you would be able to do those examples on your own. All right, I'll see you in video 2.